Decision-making under risk. Normative theory of decision-making. Welcome. This is the first of a 3-lecture series that will introduce the radiologist to decision-making. The goals of this lecture are to introduce the basic lexicon on decision-making, in particular the concept of utility, and to explain the standard utility theory. The standard utility theory is a normative theory of decision-making. Let us ask ourselves, why is it important for radiologists to understand how people make decisions under uncertainty? Why do we need to understand decision-making at all in our pursuit to demonstrate the value of imaging? The purpose of imaging is ultimately to aid in decision-making that results in improved outcomes for our patients. We are essentially uncertainty managers. Imaging is only a tool to manage that uncertainty. If there were other tools more effective, we would be using them instead. We manage the uncertainty of our referring physicians and patients, and in the process we introduce our own uncertainty. We deal with partial information, of which we must make best use of. Most importantly, we do not know the outcome. In many ways, the maladies in decision-making under risk, that is, when you don't know the outcome, are also shared by the medical profession. To understand why imaging is overutilized, we must understand the irrational. To predict the irrational, we need to define the rational and find ways for reasons why there is such a systematic departure. Historically, economists have always assumed that people are rational agents. They maximize what they value. The rational agents theory actually stems from political philosophy by John Stuart Mills and Jeremy Bentham. This is known as utilitarianism, which is essentially the greatest good for the greatest number. In terms of decision-making, von Neumann and Morgenstern developed the standard utility theory, of which there are several axioms that we will discuss later in this lecture. In fact, the political philosophy of John Stuart Mills and Bentham is also to some extent shared by the policymakers when they allocate healthcare resources. They do so in order that the most number of people get the most amount of health benefits for the least amount of cost. Before we delve further into decision-making, let's introduce some terminologies that decision scientists and economists frequently use. The normative. This is the ideal. This is what ought to happen. Descriptive. This is reality. This is actually what does happen. Bias is a departure from the normative. Prescription is an effort to reduce the bias to make the decision-making more like the normative. In fact, this is a useful way of thinking about many problems. What should happen, what does happen, why the departure, and what one can do to reduce that departure. The normative is determined by models and theories. Researchers unravel the descriptive. The model is refined and new predictions are made. The process is iterative and recursive, with research and model acting symbiotically. Here is a term you will hear ad infinitum during the quest for showing value in imaging, and that is utility, What is utility? Utility is anything we value and wish to maximize. That includes wealth, happiness, leisure time, fame, knowledge, loyalty, and so on. A rational agent is a utility maximizer. Now there is some circularity in the definition. For example, we know that for a thrill seeker, his utility is danger and thrill. How do we know that? Because that is what he maximizes. And he is a rational agent. Why is he a rational agent? Because he maximizes what he values. Now, if you are unsatisfied with the precision of this definition, don't worry. Economists have been going back and forth with arguments about what exactly is utility and what exactly is value. Like the discussion about free will and its true existence, this is not something that can be closed that easily. But leave that aside. This is an important principle to appreciate for many reasons when one is trying to show value. Utility may be single dimension, such as wealth. More commonly, of course, utility is of multiple dimensions, such as wealth and leisure. Often there is a conflict between two utilities, such as wealth and leisure. This means that there is a net trade-off, and that trade-off depends on the relative preference for wealth versus leisure, and also how much of one already has. Just as there are utilities, there are disutilities, which is essentially a utility with a negative valence. The major utility in healthcare is quality associated life year. There will be an entire lecture on quality associated life year. But there are other utilities, such as satisfaction of the patient and the physician. And there are utilities that arise by avoiding disutilities, such as anxiety, regret, uncertainty, and fear of litigation. In thinking about the value of imaging, it is important to consider an entire bandwidth of utilities, both the tangibles and the intangibles. Of course, I will make a case that a lot of the intangibles can be quantified in the same way as the tangibles. It's probably worth comparing metrics and utility. Are they the same? If they differ, how do they differ? Ideally, metrics ought to capture the utilities for which we tout value. And this, of course, includes health benefit units, such as quality associated life year. This is the most commonly used metric. When one makes comparisons between the United States and other westernized countries about the delivery of the healthcare and the outcome, this is a metric that is often used. There are other metrics, such as costs, and for imaging, turnaround time of report, physician and patient satisfaction scores, radiation dose, and probably increasingly proportion of negative studies. One thing I want you to think about when thinking about metrics is ask yourself, do the metrics conflict? That question is very important because ultimately we want to reduce utility to a single currency that has properties of transitiveness and fungibility. Now that's just a fancy way of saying that you can add them, subtract them, substitute them, and compare institutes by the score that they attain on these various, or on this single currency. As I mentioned earlier, policymakers try and encompass the principles of utilitarianism, which is to try and maximize the utility for the most number of people. In the case of healthcare, they would look at what activities yield the highest quality associated life years for the most number of people for the least amount of money. Back to decision making. Decision scientists often use the term gamble. Now, it's not gamble strictly in the Las Vegas sense, although the principles are the same. A gamble is any choice whose consequences are not known. It can be something very simple, such as whether or not to take an umbrella to work, or more consequential, such as the decision to go to. When thinking about a gamble whose outcome is not known, economists divide uncertainty into two groups. One is called risk, and the other, they leave it as uncertainty. What's the difference? Risk is when you think you know the probability of an event. It doesn't mean that you know that the event will surely occur with certainty, but you have some idea of the probability that it will or will not occur. Uncertainty is when you do not know the probability of that event. You neither know the numerator nor do you know the denominator. Hold this distinction in mind. We will talk about value imaging in converting uncertainty into risk. So a gamble is choosing between prospects whose outcomes are not known. Risk basically means any probability of outcome other than 0 or 100%, or other than certainty or impossibility. Prospect, a term that will be used quite often, is simply an option, and the outcome is the final result. It is worth deconstructing a decision to illustrate some of the semantics. Consider this rather trivial dilemma. Should I go to the Poconos or the Delaware Water Gap? I am uncertain whether it will rain or not. I want to enjoy a nice sunny day's hike. The option is between Poconos or Delaware Water Gap. The state is the weather. The outcome is a sunny day's hike. The probability of the state is how likely it is going to rain. The value of the outcome is that desirability of good weather so that I can hike. The crucial thing to understand over here is that we control the option that we choose, not the outcome. Let us define another term, expected utility. A risky prospect, which is a prospect that is neither impossible nor certain, has a certain probability of occurrence, yields an outcome with a utility, U, and probability, P. Utility is the desirability of that outcome, and probability, P, refers to the chances of its attainment. The expected utility is a product of probability of the outcome multiplied by the desirability. So if option O1 has a utility U1 occurring at a probability P1, and option O2 has a utility U2 occurring at a probability P2, the expected value of option 1 is U1 P1 and option 2 is U2 P2. This is really a very simple concept, and I will illustrate it by giving an example of a lottery. The expected utility of a lottery in which one has 50% chance of winning $100 is simply $100 multiplied by 0.5, which is $50. The expected utility if there is a lottery in which there is a 25% chance of winning $200 is also $50. The expected utility if there is a 50% chance of winning $100 and 50% chance of losing $100 is 0. We would like to quantify risk aversion, which is not constant between individuals, nor is it constant amongst a certain individual. This is done by asking the willingness to pay for a lottery, such as the aforementioned lottery. If the willingness to pay to participate in a lottery is less than the expected utility of the lottery, one is said to be risk averse. So in the example I gave, in which there was a 50% chance of winning $100, if one paid less than $50 to participate in that lottery, they would be said to be risk averse. If the willingness to pay was greater than the expected utility of the lottery, one is said to be risk seeking. That is, if they paid more than $50 to play in a lottery in which there was 50% chance of getting $100, they were said to be risk seeking. If the willingness to pay was exactly equal to the expected utility of the lottery, the person is said to be risk neutral. Okay, now that we have cleared up the lexicon, introduced ourselves to some very basic concepts, it's time to talk about the axioms of the standard utility theory. What we're saying is that the rational actor is a utility maximizer. If that is so, there are certain rules that must be followed. First, completeness. One must prefer A to B or be indifferent. Being indifferent is also a choice. But a rational actor must have a preference. Second, dominance. One should choose a dominated strategy. Third, cancellation. A choice between two alternatives should only depend on the attributes that differ between them. For example, let us say you're choosing between two apartments. The things that you value include rent, commuting distance, and safety. Let us say that both apartments are the same in terms of rent and commuting distance. Then the only thing that should make a difference between the two is the safety. Fourth, there should be transitivity. That means if one prefers A to B and B to C, then one must prefer A to C. Finally, there should be invariance. Decisions should not be based on the way the alternatives are presented. What is the importance of transitivity? If I prefer A over B, B over C, and C over A, then this creates a paradox. I will pay $10 to exchange C for B because I prefer B over C, then $10 to exchange A for B because I prefer A over B. Finally, I will pay $10 to exchange A for C because I prefer C over A, and so on. This creates a money pump. Okay, so finally, we are ready to introduce Homo economicus, the rational man. He is a utility maximizer. He maximizes what is valued. He chooses the option out of multiple options with single outcome that affords the maximum utility. He chooses the option out of multiple options with multiple outcomes that affords the maximum utility. He can make appropriate trade-offs. He is facile with probabilities and is emotionally neutral. and is likely a figment of our imagination. In the next lecture, we will go over research descriptive that actually breaks the myth of the rational man. We will introduce prospect theory and other descriptive theories of decision making.